Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is basic conditions and loops in C++. Before proceeding, make sure that you have already watched these other videos first. A condition statement evaluates some test expression, which is written within parentheses. Because this test expression is true, the condition statement will then perform the subsequent statement. But this test expression is false, so this time the subsequent statement is not done. Various conditional operations exist for testing that something is less than something else, or greater than, less than or equal to, greater than or equal to, or not equal to. Each of these relational operators produced a result having a Boolean data type. But in C++, that's actually not so important. As far as these conditional statements are concerned, you could have used any numeric expression. For example, the computer does perform this outputting statement because this numeric test is non-zero. But this test expression is 0, so the outputting statement is not done. When we had used a relational expression, it had produced a Boolean, and then that Boolean had automatically coerced into a numeric value, where a true test coerced into a non-zero value, causing the statement to be performed, or a false test coerced into a 0 value, causing the statement to be skipped. Here, this code is deciding whether or not to perform one single outputting statement. That decision could, instead, be about a whole block of statements. This programming ability exists for all of the basic conditions and loops that we will be discussing. Their decision-making could be programmed to be about one single statement or about a whole block of statements. You can add an else clause to the end of a conditional statement. Since this condition tests to true, the first statement block is done, but the else block is not done. But since this condition is false, the first block is skipped, and then the else block is done. Consider this sample code. Inside of a conditional statements test expression, we're making a function call, which we've somehow programmed to return a random number. If that number is a single-digit number, then the conditional expression is true, and then we do that outputting statement. Now, imagine the goal of our software is slightly changed. We now want to repeatedly generate random numbers, again and again, for as long as they are all single-digit numbers, reporting each time, only stopping when a big enough number gets randomly generated. This program is bad because we're repeating ourselves. In fact, we need to write an infinite amount of source code to cover the extra lucky situation of a long run of small random numbers. A better solution is to use a while loop. This source code will do what the previous source code had been trying to do. First, the condition is tested. If it's true, then the statement block is done, and then we would loop back to retest the condition once again. This looping process of test the condition, do the block, test the condition, do the block, can repeat as many times as it needs to. Within the while loop statement block, you sometimes might want to write a break statement. What happens when the computer reaches a break statement is that this whole while looping mechanism gets completely aborted, and then the computer will jump down to whatever code immediately follows your while looping code. There's also a continue statement which is like a break statement, except only the current pass through the statement block gets aborted, and the computer will jump back to retest the condition once again, so it maybe will continue the looping process. Notice that during the first time through this while loop, we test the condition first and then possibly do the statement block. Consequently, it's possible that the statement block might never get done at all if that first testing of the condition is false. But in some situations, our goals might want us to guarantee that the block is always done at least one time. If that's the case, program with this do while loop. We again have a pattern of do the block, test the condition, do the block, test the condition. That can repeat as many times as it needs to. The only difference is that this time we're starting with a do the block, so that we know it'll happen at least that one time. A while loop is often used in a programming pattern called indexing. There's some index variable, which is both being tested by the loop's condition and being updated by the loop's statement block. This example code uses indexing to print out all of the numbers from 0 to 10, stopping before it would have printed the 10. We commonly have math statements like this index equals index plus 1, where the same variable appears on both the left-hand side and the right-hand side of the assignment. There is a shortcut that gives you this same effect, but typing less source code. This shortcut is called a compound assignment statement. Many other operators also have their compound assignment forms, including subtraction, multiplication, and even bitwise math operators. Since the amount being added to this variable is 1, there's an even shorter way to write this code by using this increment operator. By the way, C++ also has a decrement operator. The increment operator could be written either as a prefix or as a postfix operator. That only makes a difference if your code is doing two things at the same time, both accessing the value of this variable and changing its value by incrementing. If you write it as a prefix operator, then the changing happens before the accessing. If you write it as a postfix operator, then the accessing happens before the changing. This indexing form is so common that C++ has a special syntax just for it called a for loop. The for loop will work identically to this code. Its purpose is merely to gather together the key indexing information so that it can appear in one place. The part of the code where we're setting the index variable's initial value so that it starts out at 0, that part gets moved so that the programmer now types it within these parentheses at the beginning. And the part of the code where we're updating the index variable, that part also gets moved so that the programmer now types it, also within these parentheses, at the end without any semicolon after it. Notice how a couple of semicolons are used for separating these three clauses of the for loop. Every for loop will have these same three clauses, but the way you choose to program what goes into these clauses, that's entirely up to you. They could be any C++ statements that make sense for your own situation. You could even squeeze multiple statements in there. For example, consider this while loop. This code prints out each of the powers of 2 up to 2 to the 10th power. For the part where we're giving variables their initial values, we're now assigning to two variables. And for the part where we're updating variables, we're updating both I index and I power of 2. For loops already use semicolons for separating their three clauses. So how do we squeeze in both the assignments of I index to 0 and I power of 2 to 1? Although we normally have a semicolon symbol between C++ statements, the C++ language lets us instead use a comma symbol specifically for this situation. We also need to use the comma symbol for the variable updating clause of this for loop. A for loop must have all three of its clauses, but you're not required to actually do anything in them. If you don't need to do anything in a for loop clause, then just leave it blank. But the semicolon symbols are still required to be there. Instead of our for loop's first clause using an assignment statement, it could instead define that variable, also giving it an initialized value. When the for loop is completely done, that variable will go out of scope. Although there used to be some obsolete compilers which didn't properly ensure that their variable went out of scope this way like it should. In modern C++, the first clause of a for loop can now also be used in an if or switch statement. Any variable that happens to be defined this way will go out of scope after the end of the statement block. In fact, that's usually the reason why this feature is being used in the first place, for the convenience of having some new variable that is only in scope within this ifs condition and body.